We're going to look at another example where a system of differential equations arises, and that's in electronics. So you have a circuit here with a resistor, an inductor, another resistor, and some electromotive force. So an electrical network having more than one loop, as this one does, see, here's a loop going this way, and here's a loop coming in and going out this way, gives rise to simultaneous differential equations. According to Kirchhoff's first law, when a current is split, the total going into a junction is equal to the total coming out. So in other words, if I1 goes in, then I2 plus I3 is what's going out. And so we can write this, right, and know that we're telling the truth. So according to Kirchhoff's second law, the sum of the voltages in a complete circuit is equal to 0, where the electromotive force across the circuit is equal to the sum of the voltage drops across the circuit. And that means examining the loop A1, B1, B2, A2, A1, that would be this one. We get the product of the current and the resistor plus the amount of inductance times the derivative of I2, and again, you might have to pick that up from electronics text why it's a derivative there, plus I2 times R2, that's this resistance, is equal to the electromotive force, because this circuit has a net voltage of 0. Right, so this amount is going to be equal to what these amounts would turn out to be. So now, in the other loop, that's this one, we get the electromotive force to be IR1, that's what happens here, and then plus L1 times, plus L2 times dI3 dt. So the derivative of I3 dt, that would be crossing this. So substituting for I1 from this equation, we get L1 dI2 dt, that's here, plus this R1 plus R2 times I2. Remember, we've replaced this by I2 plus, we've replaced this by I2 plus I3, so we got R1 times I2 plus R1 times I3. And here's the R1 times I3, here's the R2 times I2, and, the R2 times I2, and then from here we get the R1 times I2. So therefore, that's just this equation with I1 substituted as I2 plus I3. Similarly, we could substitute into this one because our I1 is replaced by I2 plus I3. And see, here's the R1 I2 and the R1 I3 from this substitution. And so we got our two unknown functions, I2 and I3. And there is our system of differential equations saying how they work together.
Okay, bye.
Bye.